So thanks a lot. Here it is Enrico Ronchi from Lund University. And today I will discuss about a research roadmap for evacuation models using fire safety engineering. The motivation of this work is that I've been involved in a variety of projects concerning evacuation modeling and when I talked to Brian about giving a presentation in this conference, I thought that instead of focusing on just one project, I could give an overview of the different things I've been involved with and how this can be translated into future research in the area of evacuation simulation. I have a quite long list of people that I have to thank because I've been involved, as I said, in different projects with different people from different institutions. And as I said, what I present today, it's not only my work, but it's also the result of a collaboration with different people. As I said, somebody from Lund University, different companies in Sweden, also different experts in different areas concerning evacuation simulations. So why do we talk about a research map? A research roadmap is going to be the first thing I will talk about in this presentation. Why is this important? Why I come up with this topic today? And then I have a list of 5 different priorities that I'm suggesting here for future research in evacuation simulations. And what I want to bring up today is not giving the final answer of what are these priority areas, but mostly open up a discussion on what you think, what the whole audience and the whole community, which involves different people, think are supposed to be the priorities in the area of evacuation simulations. And as I said, these areas, they mostly come from previous research that I've been conducting recently. But as I say, I'm open to listen to more areas that you think are important. So why a research roadmap is the first big question. This comes from the fact that on one point, we researchers, we conduct different projects, we do different research investigations, and we want to see how much of this work that we do is later implemented in evacuation simulations. So both from the point of view of the model developers, so what do they take out of our work, and both from the point of view of the users, so how they make use of our data set that we collect and so on. I think this is particularly important because sometimes it happens to me that I see applications in which we look at some, I don't know, calibration of a model for a certain case study, and then I see, okay, but what? This has not been taken into account. We know there is research on this, so why not putting this together so that more users can make use of it and more developers can make use of the research conducted? The second issue here, so one issue is the research that has been done, but is not fully implemented today in evacuation models. The second issue here is the future areas that should be prioritized in evacuation modeling research. This is quite of a problem because most of our research is driven by the funding that we get, but when we apply for funding, we can decide on which area we should go. So the idea here is to get some feedback from the user and the developers of what they think is the most important, are the most important areas, and then, let's say, discuss on what are the priorities and what are not the priorities. And then this is the way to the future evacuation models. Benefits. What are the benefits of this? The benefits of a research roadmap are huge because, first of all, from the researcher point of view, you can see that you are not wasting your efforts in vain. So that your research that is relevant and is going to be implemented in future uses of evacuation models, in future developments of evacuation models. This is a bit of a concept that is valid for any type of models. And I know in the FTS, the fire modeling community, there are many discussions on, let's say, avoiding the application of efforts and avoiding, let's say, working on the prioritization of the areas that are more important. So from the research perspective, it's very important that we work on research that is then implemented in the future model uses. From the user's perspective, if we have research that can be implemented in models, this is then reflected in improved features, so we will have models that have better features and also increase credibility because we will have some models that have been based on more research. From a developer's point of view, of course, this is fantastic for them because they can get more increased model capabilities and more users, because in some areas of evacuation simulations, sometimes there are some uses that are limited by the current capabilities of the models, which can instead be expanded if the models will be able to cope with certain scenarios. It's a bit what we discussed today. I mean, today we discussed a couple of cases, I don't know, the hospital evacuation and how to tweak the models to get this. But again, this is just an example. There are many cases for which this is valid. Different type of population, different type of scenarios, and so on. And finally, when we talk about authorities having jurisdiction, this also is reflected to the increased trust in the results that we get, which is very important, because if we have models based on more research, we get more credibility in what we do as model users, and then we have, let's say, better results. The first thing that I want to point out, and that I take for granted, the model validation is the priority one. So this has been hugely discussed in different type of fields. I come originally from the transportation modeling fields when they work with transportation models. I've been approaching the fire modeling things, and now today I work with the crowd evacuation simulations. But everybody talks about the same. Everybody say the same. We need more experiments. We need more validation. So this is out of question. I'm not going to even question this. And this is mostly linked to the fact that we have some theories, we have some data sets, and we have to see how these are implemented in today's models. And what I want to bring up today is that in a couple of areas, in a couple of, let's say, more specific parts of evacuation models, sometimes we have models based mostly on purely theoretical assumption rather than being data-driven, fully data-driven. So I want to bring up this and see how you react to this. What are the areas that I'm suggesting here? As I said, these 5 areas are not necessarily the final areas that should be the priority, but it's to bring up the discussion. There might be other people bringing up other ideas on this. But this, as I said, it comes from the fact that we have been doing research at Lund University in this area, given the needs that we've been seeing in different companies and in different fire safety engineering applications. The first area that I have here is factors affecting people movement. This is mostly associated with the fact that some of the factors that, some of the ways the models today, evacuation models simulate people movement are, let's say, based on simplified assumption. And I want to discuss what assumptions we should start questioning that today are not questioned yet. Then we have road choice modeling, and this is also quite important because again, I will show you, and I will discuss that most of the models today, they work with some basic assumption of route choice, like for instance, user-determined paths of people, or shortest routes, quickest route. But should we look at this in a different way? Should we look at this in a different perspective? The third thing is what I call behavioral uncertainty. I've been doing quite some research on this when I was working at NIST. And it is associated with the fact that we deal with humans, we deal with the human factors. So when we represent the process of evacuation, we have this additional component that is driven by the fact that we deal with humans and we deal with people. So how do we deal with the fact that we have mostly, in most cases, probabilistic models? The point number 4 is the integration with other models. This is another thing that I want to stress a lot. We get very, very many applications of evacuation models coupled, for instance, with fire models. I'm involved, for instance, in projects where we look at the implementation of crowd evacuation simulation together with traffic models. Are there any other areas that can be coupled with crowd evacuation simulations? What do we actually need to perform a proper integration between these different type of models? And the last thing is, the last factor is on validation methods. When I talk about validation methods, I don't not talk about validation per se, so I don't talk about the data collection, so we need more data. Everybody knows this, that we need more data. But I talk more about the use of this data set and how do we use them to compare evacuation simulation results and experimental results. Let's start a bit with the factors affecting the people movement. How do most of the evacuation models work today? They generally have a distribution of unimpeded walking speeds, and then you have a constant value that is drawn from this distribution using different type of methods, like as we mentioned before, one of the presentation with pseudo-random algorithms that pick one of these numbers, and then we have a generation of impeded speeds that they mostly depend on the impact of obstacles and other people. This is very much known. These type of models are also called as self-driven particle models. So they work with, for instance, a constant initial speed that is subject to perturbation. This is like, for instance, social force model will work like this. What is the future? The future is that probably we should not look only at the distribution of our impeded walking speed and a constant value for each person. But this, the starting point, the desired walking speed, the unimpeded walking speed, should this be depending on risk perception and motivation? Because this is something that we see when we do experiments. So is this an oversimplification? Is this valid today? Should be valid in the future? So as I say, I just want to launch ideas on things that probably may be modified in the future and we should do research on. So the impeded speeds maybe should be explicitly affected by the impact of many variables, like for instance, fatigue, physical exertion. Some people were mentioning this before. Smoke, so visibility, reduced visibility conditions. Difference in emerging flows, this is another areas in which I've been doing research on, and so on. So I will bring up some of these variables here and tell what our research projects at Lund University have said. Should we change the way we simulate people movement? Should we look at different ways to reproduce the movement of people? For instance, some research today have shown that you can reproduce people movement in a completely different way. For instance, looking at the underlying biomechanics factors of people, so how the actual physical movement is reproduced in a crowd, and there is some research on this. Or based, for instance, on cognitive heuristics, so what does it mean? What is your perception of the environment? What is the perception of the space? Should be the way, the factor we should look at when we reproduce people movement. As I said, this is just a bit launching ideas for future research. Physical exertion. This is the first factor that I want to bring up since I've been involved in a large research project led by Lund University together with 2 Swedish companies. And we have looked at this, at the impact that fatigue has on people movement. So we saw, and it was quite clear that even we had some experiments conducted, 3 experiments conducted in full scale, so 2 stair evacuation, ascending evacuation, because this was a case that generate fatigue, and 1 escalator experiments, and also we did some experiments in the lab with the stair machine, and it was quite obvious that there was an impact of the fatigue on the capability of people to move and to perform an evacuation. And we saw, for instance, that a high pace continuous climbing may lead to exhaustion to as little as 3 minutes. So for this type of scenarios, the models that are used today probably are not the best ones, at least if we use them without taking this into consideration, because some models, they have the flexibility to use speed modifiers and so on, but this is not modeled explicitly today in these models. Another thing that I immediately wanted to bring up when I saw the results of this experiment is people taking rest affect the whole flow when we have a crowd. This means that what we call today fundamental diagram, that is the relationship between density, flows, and speeds, might be just a snapshot which consider only the people that are not affected by fatigue, while in reality this should be changed over time because people stop and impede the flow. So in reality we are using optimistic correlations to speed versus densities versus flows. And again, in this project, and you will find here, I put the reference, this is an open access report. We also developed a model for maximum vertical displacement, because this was a project on ascending evacuation, versus oxygen consumption. So we didn't look only at the walking speeds, but the reality is that we had to look on the basic fundamentals variables that affect the walking speeds. And we collaborated with a group of physiologists that work on human exertion at Lund University, and they are experts in oxygen intake measurements, muscle fatigue, and so on. So we built up heart rate measurements, and we built up a model for maximum vertical displacement versus oxygen consumption. So for the model developers, this could be a nice, let's say, future implementation. Second thing, motivation and risk perception. This is another area on which there that might be important to push research. Why? Because the constant desire and impeded walking speed might be a questionable assumption compared to what happened in reality. And what we saw from experiments is that sometimes people can speed up or reduce their speed depending on different factors, as I said before, motivation, for instance. So people we observe in experiments that when they get close to a target, they tend to speed up because they want to get out. So there is this psychological factor that today is mostly ignored in evacuation models of today. And this is quite known in sports science, but for some reason nobody brought this up, at least at the systematic level in evacuation simulations. As I say, I mentioned this one of the experiments that has been done in this project that I mentioned before, in which we saw people that when they were reaching the higher up zone of an escalator evacuation, they were actually speeding up at the end, despite being tired and reducing the speed over the entire duration. And another factor here is risk perception. So should we look at risk perception also to affect the decision that we make when we leave a building, so for pre-evacuation time, but also for the decision to speed up or not? As I said, this is something that I brought up together with some colleagues at NIST, and we work so far on a theoretical model that takes into account of fatigue and motivation. We published this in a mathematical journal because, of course, it's not validated, but the main point of the work that we did together was to bring up this and bring up new variables that should be considered in the simulation of walking speed. Smoke impact. This is something that has been done, a lot of research on this, and some of the models presented before, they also take this into consideration. The question here is that there are different data sets and there are different type of conditions in which these experiments are conducted. So studying how the walking speed is reduced in relation to the visibility conditions. We have an ongoing project at the moment with SP and Lund University. This is together with Carl Friedhoff, they're sitting there. And we are actually reviewing all the existing data sets, mostly conducted in Sweden and Japan. For some reason, these are the two countries leading research on this. And we will come up with the recommended correlation which takes into account all the different data sets and not only one, because for instance, as it is today, some of the models use one or a different data set and so on. Another factor here, difference emerging flows. What does this mean? We have observed in experiments that when a group of people merge, this can have a quite significant impact on evacuation. I know you guys at Pathfinder have done some verification testing for this in stairs, but the main thing that no model, to my knowledge, does is to allow the users to change this merging process, the merging ratio. So what we did, this was a research collaboration together with Waseda University in Japan, with Professor Sano, is to develop a simple mathematical model so that the user can modify this, because we have observed in different experiments, and I mentioned here one of the largest let's say, database, that is the NIST database on which I worked on when I was there on building evacuation. We observed that depending on the conditions of the building, evacuation conditions, you may have different merging ratio, which is quite important because this changes the order in which floors are evacuated. So our idea was to build a simple mathematical submodel that can be implemented in future models, and we have done research on this soon to be published. The second area that I have here is route choice modeling. After talking about movement speed, another thing that really is another factor that is quite important is how do we model today route choice, mostly using theoretical assumptions, so shortest paths, quickest paths, or different conditions, and how we should do this in the future. So looking at data rather than just looking at the assumption that we want to minimize the time of the evacuation with the route choice, or we want to have the shortest path, because this is not how it works. When we look at experiments, that's not how it works. I've done experiments in Lund in which there were two exits close to each other, and the first people started going to the first exit, and people start following, the majority of them do the overcrowd exit, and this happens. There is research on this. So the reason is, the reasoning behind this is, should we force our models to aim at the shortest or quickest paths, or should we go more into depth and develop more research to help the developers in order to have a better understanding of how route choice should be modeled? As I said, we did some example of this. So what we did, one of my PhD students developed a very simple cellular automata model that makes use of trajectories, of experimental trajectories, and calibrates the route choice paths based on experimental data, so purely data-driven. Of course, we will need a lot of data to do this properly in a lot of different conditions, but this should be probably the research of the future, more than tuning too much these, let's say, algorithms. This is also links to the buildings that we have today that are getting smarter and smarter with different type of smart wayfinding systems, like for instance, dynamic signage, different type of information given to people. Should we implement also smart road choice algorithms that it takes into account of the information that people get into an environment? We did some research in Lund on this, mostly looking at dissuasive signage and looking at how this can be used to, let's say, recommend people to go in a direction or another. I know University of Greenwich has done also research on this. And in principle, while the road choice modeling methods are based today on the evolution of the behavior of the agents in space, should we instead consider the whole environment? So probably we should do research on this. Then we go to the third factor, that is behavioral uncertainty. This is a topic, very large topic, that I brought up at different forums and different papers, conversation with people. When we use models based on probabilistic approach, one of the big questions is how many repeated runs should we do? And I have to say, even myself, often it happens that we go for the easiest way, so we just run a finite number of simulations without thinking too much, thinking that it's large enough. But in reality, should we not have a method that assesses how the convergence of results is in relation to the number of runs that we do? And there are methods developed for this. Together with Rick Peacock and Paul Renick and NIST, I developed a method, for instance. There are other methods that can be used. So should this be implemented in evacuation models in the future, so that the user should not just decide 50 or 100 runs, but he can decide, okay, I want this type of acceptance criteria for the convergence of my average occupant evacuation curve, or total evacuation time, or 95 percentile, or whatever is the acceptance criteria that you have. And today, I have to say that, to my knowledge, no models implement this. Other area, integration with other models. So how should evacuation model be integrated with other models? We know that some models allow, for instance, the coupling with the fire modeling. I know models that allow the coupling with traffic modeling. In the future, should we look at other things? I don't know, probably the scale of time is different, but should we look at coupling structural modeling with evacuation modeling, so a dynamic space that changes over time? Should we look at lighting modeling? This is very important when we talk about visibility as a criteria. I mean, no, I'm not expert at all at lighting, but I'm pretty sure there are quite good models out there. Should we start working on coupling this, doing research on the coupling of this with evacuation, crowd evacuation? And this is related to the fact that today we have BIM, building information modeling, that is getting huge and huge in the building industry. So we have generally a lot of information during the entire lifespan of a building. And also, we started using evacuation model for bigger scenarios. So for instance, larger disasters. Nowadays, I'm doing research on wildfires, for instance. I did in the past also research on other type of large-scale evacuation, but probably what we really need is to start working on a data transfer interface so that different models can talk to each other. Because nowadays we don't even know which inputs and which outputs are needed by different type of modeling. I mean, we know it for some of this, but there is not really a good classification of this. Oops, this one, yep. And the last area is validation methods. Recently we published a paper together with different researchers working with different models and methods. Alfie here was one of the authors of this. And we looked at different methods that are used today for validation, so for comparison of experiments and evacuation simulation. But the problem is that there is no really full guidelines on how to do this. Now that I saw some companies probably have their own, let's say, templates of results and so on, but it's different when we talk about validation, because there is no really a good categorization of what are the methods that can be used for validation and which one are the most important. So today, now there is an ongoing work at ISO, at the Technical Committee 92, Subcommittee 4, Working Group 7, and I'm leading actually a task group working on a document to try to put together all these methods and categorize them and give more information for the user in order to have, when you do a comparison, so when you do a validation testing, to have an idea of what are the available methods. That's pretty much it. I think I'm coping with the time. So conclusion, we know that validation is priority one. I'm not questioning this. What I'm bringing up here is that I suggest a list of priority areas that, coming from different experiments that we've been doing, different research that we've been doing at Lund University, might be important for the future. But again, this is not the final answer, so I'm not arrogant enough to say that this is the final answer. Absolutely, this is not the point of this presentation, but it's more to bring up a debate and listen what you think about these 5 priority areas, if you think there are other areas that should instead be prioritized, and so on. Here you have also a list of references, and most of these reports are, let's say, public, so you can read about the different models and methods and experiments that I mentioned before. Thanks.
Great. One question I have is, do you have this online as a website or a discussion forum, some way for people to discuss the different
to be honest with you, one of the first idea was this, to set up a Google survey or something like this, but I think that should be the next step.
I was thinking more like a wiki or some way for people to collaborate on the roadmap itself and edit.
We should start working on this. I'm actually willing to get feedback from both developers and users, because that's the way to go. As I said, it's not a single opinion of a single researcher or developer that is going to bring this up, but it's more a collaborative effort of the community. And there are platforms in which we can bring this up. I mean, there are SFP, IFSS, NFPA. So there are people that might be interested in this. So yeah, I want to bring this up.
I'm just thinking, as I was watching, I'm thinking, there's a lot of details here that we need to kind of address at a time and think through it.
As I say, I launch ideas. I could not go into every single project that I've been involved with.
Any other questions?
Thanks, Enrico. I was a bit surprised you didn't discuss the need to model things that happen before the people decides to move, like the pre-movement decision-making things. Do you think they can be modeled, or should they be left as a statistical data or something like that?
I see this as an important issue, but I see it linked more with the general problem of data collection and validation, let's say priority one that I don't even talk about. Because the thing is that I know there are some models. Myself, I developed a model for pre-evacuation modeling, considering different factors like social influence and so on. But the main problem was that we didn't have pretty much any data, very limited data to do any work. So probably, yes, it should be specified explicitly, but still, it goes in the big picture of having no data, really, to back up, or very limited data to back up a proper pre-evacuation model. As I said, we did some attempts. I had PhD students working on this, but again, it was based on 1-2 experiments, and in reality, we need a quite huge data set of experiments, different data set of experiments to build a pre-evacuation model.
And it also seems like something that as soon as you redistribute the model across the population, it starts to just become a statistical result, because each individual might have a different decision model, but then you get, okay, re-randomize and reposition that, and there.
Probably today is the best to deal with just with this distribution, to model this implicitly. In the future, probably we should start looking at this explicit way to look at the factors, but looking at the underlying factors that are, it's a bit linked also to this that I mentioned with cognitive heuristics. There is some research done on this. So I read a couple of very interesting papers in high-ranked journals that look at how people perceive the space around them and how this can be used to model also crowd behavior. And probably we should change completely the way we model this, not these self-driven particle models like social force model. We should completely change the way we model the movement and the decision to move, because this might be linked to risk perception, might be linked to the, say, what we see, what we perceive, and so on.
How to consider cognitive disabilities?
That's another thing. Because each of us, each individual person perceives the space in a different way. But there is research on this, but in completely different fields than ours, for instance, in architectural design or also in psychology. But we are very basic in the way we do this with evacuation simulations today.
Anyone else?
Hi, Enrico. Thank you for a brilliant presentation. It's really important to sum up all the things that have been done so far and start preparing the path for the future. I was just trying to, sorry for bringing to my area, to things that we could help in a certain way. The research that Elizabeth has been doing using surveys, this is a very old method of data gathering, but it is probably a good way of reaching a great number of people and having data, especially regarding regional differences in different areas. Naturally. Another idea I was precisely regarding cognitive heuristics that you've got in that slide is a work I developed, and I think you are aware of it, using serious games for virtual worlds in order to small scenarios and for massive data collection. Unfortunately, I'm moving from the academia to the business, so I left that research work behind me. But I think that someone could use it in order to use, I think Ruggiero has done something
Yeah,
like
that's my
that,
PhD student, yeah.
And he published a work using that. Because you can easily define some video game scenarios and use it for some especially behavioral approaches towards the way path and that kind of stuff.
I have to say that I work with different type of experiments. VR is one of those as well. We have done this type of experiments in Lund. We have our own VR lab. But at the same time, every method has its advantage and limitation. The validity that you can get with the real, let's say, full-scale experiment is always better than a VR. But depends on what you're looking at. And the same with surveys. Surveys, the good thing is that you can study attitudes and preferences of people for a large number of people in a cheap way, let's say. But my point of view is that probably we should not look into only one single experimental methods, but use a combination of them. And that's pretty much what we do in Lund, because we don't work only with one, but with different types of experiments. But surely serious games is the future. I mean, I have a project now on this, only on the use of serious games. It's just started because it's very catchy, it's cheaper than full-scale experiments, and you can get very valuable results. But again, depends on what you're looking at. Probably for wayfinding, it's a very good tool for studying wayfinding.
Okay, well, thank you very much.
Thanks.
I really appreciate it.